Welcome to a new section, data manipulation with pandas, as we can see here. So, in the previous section, we dove into detail on NumPy and its ND-array object, which provides efficient storage and manipulation of dense typed arrays in Python. Here we'll build on this knowledge by looking in detail at the data structures provided by the Pandas library. Pandas is a newer package built on top of NumPy and provides an efficient implementation of a data frame. So data frames are essentially multi-dimensional arrays with attached row and column labels, and often with heterogeneous types and or missing data. So as well as offering a convenient storage interface for labeled data, Pandas implements a number of powerful data operations familiar to users of both database frameworks and spreadsheet programs. So as we saw, NumPy's ND-array data structure provides essential features for the type of clean, well-organized data typically seen in numerical computing tasks. While it serves this purpose very well, its limitations become clear when we need more flexibility by attaching labels to data, working with missing data, etc. And when attempting operations that do not map well to element-wise broadcasting, such as groupings, pivots, etc. So each of which is an important piece of analyzing the less structured data available in many forms in the world around us. So Pandas, in particular, its series and data frame objects builds on the NumPy array structure and provides efficient access to these sorts of data munging tasks that occupy much of a data scientist's time. So in this section, we will focus on the mechanics of using series, data frame, and related structures effectively. We will use examples drawn from real datasets where appropriate, but these examples are not necessarily the focus.